Hello my dear friends, I am Shubham from LearnoHub, the free learning platform where you can study physics, chemistry, maths, biology absolutely for free at learnohub.com. So then, let's start. So friends, as you all know, we are studying your ICSE chemistry chapter number 3, study of acids, bases and salts, right? And in the previous video, we have studied what are actually acids, their classification. Now in this video, we are going to see what are actually the bases and salts and their classifications, okay? So if you have missed the previous video, please do watch because we are going to use all the basics, okay, of acids in the next video, okay, where we are going to study the properties of acids and bases, right? So in this video, as we are going to see bases and salts definition and classification till the end, okay, at the end we are going to solve some questions based on the concepts which we have learned so far, okay. So without wasting much time, let's start and let's rock. So far we have learned what are acids, the classification of acids, right? Now we are going to move towards bases, the definition of bases and the classification of bases. Simple. So what is a base? Base is simply a metallic oxide, or okay, so this is a metallic oxide. What is metallic oxide? Metal is combined with oxygen and it forms metallic oxide, okay. Or base is a metallic hydroxide, okay. So metal and OH, when they combine, okay, so it is called as metallic hydroxide, MOH. Or it is a ammonium hydroxide. Okay, ammonium hydroxide means, now you would be knowing, OH would be there, in place of metal it would be ammonium ion, NH4 plus ion, okay, we have studied its formation, NH4 plus ion. So base is a metallic oxide, metallic hydroxide or ammonium hydroxide which reacts with acid to form salt and water only, okay. Now here you have to have the emphasis on the word only, okay, in your definition, because there are some compounds. For example, there is a metallic oxide, okay, PbO2, okay, lead oxide, which is reacting with acid. It is forming salt and water, but along with it is also forming chlorine gas, okay. So then would it be a base? No, it won't be a base, because base is either a metallic oxide, metallic hydroxide or ammonium hydroxide which reacts with acid, and it would only form salt and water. Okay, so examples are, see, copper oxide, example of metallic oxide. In place of metal, just I have placed copper. Okay, so copper oxide, metallic oxide. Sodium hydroxide, metallic hydroxide. See, metal, sodium is metal, OH. Okay, so metallic hydroxide, example is sodium hydroxide, and ammonium hydroxide. Okay, it's the same. Now, how they are reacting with acids? Let's see. So this copper oxide, sodium hydroxide, and ammonium hydroxide. Okay, I am taking HCl, our very favorite acid. Now how they are reacting with it? They are forming salt and water. Okay, now how the salt is getting formed? It's very simple to write the reactions. You have to know just the concept behind it. So what is happening here? See, copper here, okay, in copper oxide, it is having 2 plus charge, and oxygen here, it is having 2 minus charge. Okay, so how you can figure out the copper is having 2 plus charge? Just try to figure out oxygen's charge. So single oxygen atom's charge is 2 minus. Okay, so if you would learn the charges on the radicals, then you would be able to figure out. Okay, so you should learn all the charges on the radicals. Okay, so O 2 minus, oxide has 2 minus charge, so 2 minus, therefore copper would have 2 plus. So here the 2 plus copper, here it is chlorine is minus, hydrogen is plus. So this plus part would react with minus part, right? Very simple. So here copper 2 plus would react with Cl minus. Now how many Cl minus would it require to balance? See, there are 2 plus charges on copper, 1 minus charge on chlorine. So 2 chloride ions would be required, right? So therefore CuCl2 would be the product formed. Very simple. Okay. Now CuCl2 is formed, therefore we need 2 chlorine here, right? In this case, what would happen? See, 2 hydrogen, 1 oxygen, what it would form? Water, H2O. Okay, this is the salt and this is the water. So see, our metallic oxide reacting with acid, it is forming salt and water only, right? Same way, NaOH, so Na plus OH minus, okay, this Na plus would combine with Cl minus, so Na plus Cl minus absolutely balanced would form NaCl. H plus and OH minus, okay, H plus and OH minus would form H2O. See, this H2O is actually H plus OH minus, okay, in this way H2O, H2O, okay. Now this is also forming salt and water only, and the same case NH4OH would form NH4Cl. How? See, NH4 plus OH minus, this plus would react with minus, okay, so NH4 plus Cl minus, charges are balanced, NH4Cl, and then what is remaining? H plus and OH minus, so H plus and OH minus would form water, okay, so it is also forming salt and water only. So when you are writing the reactions, okay, I have just shown here the charges for your reference, okay, no need to show the charges when you are writing the reactions, okay, you have to just write the reaction without any charges, okay, simply in this case, simply like this only you have to write, no need to show the charges when you are writing the reactions, don't show at all, okay. Okay, now let's see what are alkalis, okay. So alkalis are actually bases which dissolve in water, okay, or which when dissolved in water they produce OH minus ions, hydroxyl ions as the only negative ions, okay, very simple. So let's understand this thing with the help of examples. So examples of alkalis are LiOH, NaOH, KOH, CaOH twice, NH4OH. So you can either read them as this or you can take their names as well. LiOH is lithium hydroxide, okay. See, lithium hydroxide, OH is hydroxide, sodium hydroxide, potassium hydroxide, calcium hydroxide, ammonium hydroxide. We know NH4 plus is ammonium, so ammonium hydroxide in this way, okay. So these are their names. Now how these are alkalis, okay. So let's see with the help of their dissociation equations, okay. Now because they dissociate, I'm pronouncing as, or I'm reading it as, telling you as dissociation equations. So how they dissociate? See, LiOH, when we dissolve it in water, okay, it forms Li plus and OH minus ions, okay, and these are dissolved, these are present in water, so aqueous. Now why I'm telling dissociation, right? Try to remember the first topic which we have learned for this topic, for this chapter, ionization and dissociation's difference. So dissociation is actually what? It's simply the process of separation of ions. See, Li plus and OH minus ions are getting separated, process of separation of ions when in water, okay. So process of separation of ions in water, right? This is happening in water, such that these ions are already existing, okay, in the solid state of the substance which is dissolved. So see, these Li plus and OH minus ions are already existing in the solid state of LiOH, okay. These LiOH in the solid form, it is Li plus and OH minus in this way, okay, because it is an ionic compound. We have studied ionic compounds are consisting of, or their constituent particles are ions, okay. Now this is actually happening, therefore I am telling it as dissociation. This process is dissociation. Now the single arrow, okay, normal arrow is suggesting here, okay, or I am telling you this thing, that the normal arrow is because this LiOH, okay, it's getting dissociated completely, okay. Now since it is getting dissociated completely, therefore we call it as strong alkali or strong base, okay, because alkalis are actually the bases, right? Now same way are NaOH, KOH, okay, they also dissociate. Now you try to write their dissociation equations on your own. Pause the video here, okay. So again unpause it. Now how it would be? Very simple, Na plus and OH minus, correct? So Na plus aqueous, OH minus aqueous, okay, these are in water. Then K plus OH minus for KOH, okay. Now since these are strong acids, we have written their dissociation equations like this. Now moving ahead to these strong alkalis, not acid. Now moving ahead to these alkalis, calcium hydroxide and ammonium hydroxide, these are weak alkalis. Okay, so we are representing it with this arrow. Now weak alkalis means they are not getting dissociated completely. Very simple. Now they are not getting dissociated completely, but some of them are getting dissociated, right? So how they are getting dissociated? Same way, the ions would separate. So we know calcium hydroxide is made up of calcium Ca2 plus ion. Okay, we have studied it in the ionic bonding, right? About Ca2 plus, okay, calcium oxide ionic compound. So same way, calcium hydroxide also we can understand how it is getting formed. Ca2 plus, okay, one ion of Ca2 plus and two ions of OH minus. So see, 2 minus 2 plus, charges are balanced, calcium hydroxide, CaOH twice. So they would just split up, they would just separate, okay, in these two ions, Ca2 plus, okay, and 2 OH minus. So 2 OH minus, okay, aqueous. Same way, NH4OH. So it's like the NaOH only, NH4 plus OH minus ion. Okay, it would dissociate, and again it is also a weak alkali, sorry. Okay, NH4 plus aqueous plus OH minus aqueous. Very clear? Okay, so these are the dissociation equations of all these 5 alkalis. Now very much interesting thing. See, all alkalis are bases. Okay, because we know, right, alkalis are bases, right? So all alkalis are bases simply, but all bases are not alkalis. Okay, now since all alkalis are bases, by definition only we can understand, or else we know these all are alkalis, and these alkalis react with acid to form salt and water only. Okay, so these are bases actually. Okay, but all bases are not alkalis. Okay, ulta is not possible, ulta is not actually all the time correct. Okay, all bases are not alkalis. For example, AlOH thrice, FeOH thrice. AlOH thrice is aluminium hydroxide. Okay, so what would be its name? FeOH thrice, iron hydroxide, right? No, ferric hydroxide. Okay, some names are derived from Latin. Okay, so ferric hydroxide. Now these two hydroxides are bases because they react with acids and form salt and water, but they are not alkalis because these two hydroxides, when we add them in water, they remain as it is. Okay, so since they remain as it is, which means that they are insoluble, right? Insoluble, or they don't get dissolved. So if they are not getting dissolved itself, so then no question of producing OH minus ions, right? So these bases are not getting dissolved only, so they cannot be alkalis, because alkalis are those bases which dissolve in water and produce OH minus ions. Now these bases don't even dissolve in water only, so they cannot be alkalis. So therefore we can say that, so therefore see, all bases are not alkalis. Okay, now we have seen the definition of bases, dissociation, okay, definition of bases, definition of alkalis, and dissociation of alkalis as well, correct? Now let's move ahead to the classification of bases. So here we are going to classify bases based on only one type, okay, based on acidity, like we have classified acids based on basicity. Okay, so the terms are exactly opposite. In case of acids, we have classified it based on basicity. In terms of bases, we are classifying it in the terms of acidity. Okay, so very easy to remember. Now before moving ahead how the bases are classified based on acidity, let's see first what actually acidity means. Okay, so it's like similar to that of basicity. Okay, so what is the acidity of a base? Acidity of base is simply the number of hydroxyl ions, okay, which is produced by dissociation, separation of one molecule of base, okay, in aqueous solution. Okay, now let's understand this thing. So I'm taking an example of NaOH. We have studied this right now. NaOH, strong alkali, right? Strong base. Now this is getting what is happening? See, NaOH is producing, so NaOH is getting dissociated into Na plus and OH minus, right? So what is produced? OH minus ions are produced by dissociation of one molecule of the base, okay, in aqueous solution. Clear? Now what is acidity? The number of OH minus ions which are produced, okay. So here only one OH minus ions is produced, okay, after the dissociation of one molecule of NaOH in aqueous solution. So therefore the acidity of NaOH is 1, okay. Very simple. Clear? Now in this way the bases are classified into mono, 1, right, acidic. So in the acids case the classification was monobasic, right? I have told you the opposite term would come. So monoacidic base, okay, last would be the base term, right? Before base that would be opposite term. So monoacidic base, right? In this way diacidic base, 2, di means 2, tri means 3, okay. So based on the acidity here, when those bases which are having acidity 1 are monoacidic bases, those bases which are having acidity 2 diacidic bases, those bases which are having acidity 3 triacidic bases, okay. Very clear? Now let's see the examples, okay. But before moving to examples, how to define them? So same way, I'm keeping the things simple. So same way we have to define how we define the acids, same way we are going to define the bases also, this basis. So monoacidic base means the base which is producing one hydroxyl ion by the dissociation of its one molecule in aqueous solution. Similarly, diacidic means a base which is producing two OH minus ions by dissociation of its one molecule, okay, in aqueous solution. And same way, triacidic, the base which is producing 3 OH minus ions by the dissociation of its one molecule in aqueous solution, okay. Very simple. You have to just remember the definition of acidity and then you can write the definitions of all these 3 types of bases. Now let's see the example. So monoacidic bases, NaOH, just now we have seen how it is getting dissociated and producing one OH minus ion. Same way we have already seen how NH4OH, okay, is also getting dissociated into NH4 plus ion and OH minus ions, right? We have just seen a few minutes ago the dissociation of alkalis, right? So in that slide we have learned how NH4OH is dissociating into NH4 plus and OH minus ion. So it is also producing one OH minus ion, therefore it is also having acidity 1. And like this, another example is KOH, LiOH, okay. We know they are also producing one OH minus ions, okay, after dissociation. Now no need to again write their dissociation equations, we already know them. Another example, okay, next diacidic basis example is calcium hydroxide, okay. We have already seen how it is producing 2 OH minus ions, right? And moving to triacidic. Triacidic one is AlOH thrice, aluminum hydroxide, and FeOH thrice, okay, thrice, ferric hydroxide, okay. So I have already told you the name ferric, okay, hydroxide. Now if you would have studied the radicals and their charges, you would be knowing, okay, you would be knowing ferric means Fe3 plus, okay. We call Fe3 plus ion as ferric, and ferrous is Fe2 plus, okay. So when Fe3 plus ion is there, and see 3 OH minus ions, so Fe should also have 3 plus charge, right? 3 minus charge, 3 plus charge on Fe. So Fe is having 3 plus charge, which means that it is ferric. So ferric hydroxide. If FeOH twice is there, so it would be ferrous hydroxide, okay. Very simple, the naming. Now this AlOH thrice and FeOH thrice, now you would say, sir, they don't get dissociated or they don't even dissolve, right? First of all, they don't even dissolve in water, okay. So their aqueous solution is not getting formed. So then how you are telling that they are triacidic, they are having acidity 3? So for such bases, okay, which are water insoluble, acidity is equal to the number of replaceable OH minus ions in one molecule of the base, okay. So here you can see that this definition of acidity is applicable for such bases which are insoluble. And what is acidity? Acidity is equal to number of replaceable OH minus ions. So here there are 3 OH minus ions which are replaceable. Here there are 3 OH minus ions which are replaceable in one molecule of that base. So therefore they are triacidic. Now what you would now you would ask again, what does this replaceable means? Okay, so let's see an example. Okay, for understanding this thing, replaceable means, okay, so I'm having this AlOH thrice aluminum hydroxide. Okay, when I'm treating it with acid, so these OH minus ions are getting replaced. Okay, so these 3 OH minus ions, 3 of them are getting replaced by whom? The negative part, right? See, this is the negative part would replace negative part. So this Cl minus, okay, are approaching this Al3 plus. Here Al would be 3 plus, because here there are OH and 3 OH. So 3 OH means 3 minus. 3 minus means Al would have 3 plus. So Al3 plus is approached by Cl minus. But it won't be happy with one Cl minus, right? It needs another 2, right? It needs two more Cl minus. So what would be total? 3 Cl minus. So Al3 plus and 3 Cl minus would form AlCl3, right? Now what has happened? This OH minus ions are being replaced by Cl minus ions, right? And AlCl3 is formed. Now this we need 3 Cl minus ions, right? So for that I am putting here 3. So what is happening here? 3H plus are there, okay, 3 OH minus are there, they would form 3 water molecules. So from this reaction what we can observe is this OH minus ions are getting replaced. Okay, how many OH minus are getting replaced? 3 OH minus ions are getting replaced. Therefore its acidity would be 3. Okay, same way we can write the equation for FeOH thrice also. FeOH thrice, in FeOH thrice case also 3 OH minus ions are replaceable. They are also getting replaced. So far we have seen the definitions of acid and their classification, definition of base, definition of alkali and their classification as well. Now it's time to move ahead to the third part, right? The salt. Now let's see what actually salt is. So we are going to see 2 definitions of salt. First one is, salt is actually simply a compound which is formed by complete or partial replacement of whom? Of ionizable hydrogen atoms. Okay, so this term is very important. Ionizable hydrogen atoms of an acid. Now, by which we are by whom we are replacing these ionizable hydrogen atoms of acid? By metallic ion or ammonium ion. Okay, so let's understand this with the help of examples. So partial and complete replacement. So first I would take the example of complete replacement of ionizable hydrogen atoms of an acid by metallic ion. Okay, and let's see the compound which is formed. Okay, that is the salt. So first I am taking this acid, sulfuric acid, as you all know. It has 2 ionizable hydrogen atoms. Okay, which means that the sulfuric acid is willing to give this 2 hydrogen atoms as H plus ions, correct? So this sulfuric acid, now these 2 ionizable hydrogen atoms, I have to replace it with the metallic ion. So that metallic ion should be of a compound which would react with sulfuric acid. So acids react with bases. Okay, so I would take an example of base like NaOH, which is also having a metallic ion like sodium, Na plus. Okay, now this Na plus ion is going to replace completely the ionizable hydrogen atoms, okay, of this acid, and what would form? Salt, correct? So Na, here is only 1, so from here 1 Na plus would be formed, but we need 2 Na plus, right? 2 Na plus to replace 2 H plus, because we are completely replacing the ionizable hydrogen atoms of acid. So in order to replace this 2H plus, 2 Na plus are required. So I am just taking 2 NaOH here. Okay, so 2 Na plus are now there with me. So this 2 Na plus, now out of this H2SO4, 2H plus, it's like we can write it in this way, 2H plus and SO4 2 minus. Okay, this H2SO4 is. So okay, so now these 2H plus are being replaced by 2 Na plus. So I would here write 2 Na plus. Now what would be the compound formed? 2 Na plus and SO4 2 minus would be 2 atoms of Na. So I would write Na2 here, okay, and SO4, right? So Na2SO4. Okay, Na2SO4. So this would be our compound formed Na2SO4 by complete replacement of the ionizable hydrogen atoms of an acid, here see 2H plus, by a metallic ion, okay. And then what else would form? See here 2 OH minus are also there, okay, apart from 2 Na plus. Here after this 2H plus and SO4 2 minus, this SO4 2 minus is getting combined with this 2 Na plus. So what is remaining here? From H2SO4, SO4 is going with Na, okay. What is remaining is 2H plus. So here 2H plus, okay, SO4 2 minus is going with 2 Na plus. So remaining is 2H plus. So this 2H plus and this 2 OH minus from this molecule, okay, they would combine, they would form 2 water molecules, because 1 H plus 1 OH minus would form 1 water molecule, another H plus another OH minus would form another water molecule. So 2 water molecules would be formed, okay. So the reaction, see, acid plus base gives salt plus water, okay. Now let's see the partial replacement of the ionizable hydrogen atoms of an acid. So very simple, let's take the same example, okay. I am taking H2SO4 as my acid. Again I am taking the NaOH only, but here now in this case there is partial replacement, which means only one H plus would be replaced, okay, out of this 2 H plus, okay, which means that there are 2 ionizable hydrogen atoms, right, but out of them only one ionizable hydrogen atom would be replaced, one would remain as it is. So how it would now dissociate? See, means how it would be, this H2SO4 we can write as H plus, and what is remaining with it now? HSO4, okay. One H is going, so remaining is HSO4 minus, okay. Now you can use the trick to find out the charge. SO4 has 2 minus, 1 H is along with it, so 1 H plus, right. So plus 1 minus 2, what happens? Plus 1 minus 2 is minus 1, so HSO4 minus, okay. Now this 1 H plus is getting replaced by 1 Na plus, right, very simple. So this Na plus is coming here, okay, and it is replacing this H plus. So what would form? Na plus and HSO4 minus, they would combine, they would form NaHSO4, okay, NaHSO4, and this is our salt, right, the salt which is formed by the partial replacement of the ionizable hydrogen atoms of an acid by a metallic ion, okay. Now remaining, what would be remaining here in this molecule is OH minus, right, and from here H plus is remaining, right. HSO4 has paired up, means bonded with Na plus. So what is remaining? H plus is remaining. So H plus and OH minus would form water. So again acid plus base gives salt plus water. Very clear. So this is the complete replacement, this is the partial replacement example. Now let's see the second definition, the ionic definition of salt, okay. So what ionic definition says? Salt is a ionic compound which dissociates in water, which means the ionic compound, okay, is made up of ions, and these ions are getting separated, okay, separated in water to yield positive ion other than H plus and negative ion other than OH minus, okay. Very simple. Let's take an example to understand this thing. This definition, NaCl, okay, this is my salt, it is an ionic compound. Yes, I know NaCl is an ionic compound, and when I add it in water, when I dissolve it, okay, what is happening? This Na plus and Cl minus ions of this NaCl are getting separated, which means it is dissociating in water, right, are getting separated, it is getting dissociated, okay, aqueous. Now it is getting dissociated to yield positive ion other than H plus. Yes, Na plus, it is the positive ion other than H plus, and negative ion other than OH minus, Cl minus, it is the negative ion other than OH minus. Very simple. Now let's see the classification of salt, the types of salt. So we are going to study 3 types of salt, okay, in this chapter. First is normal salt, okay. So yes, this is a normal salt. Then second is acid salt, and third one is basic salt. Now these are abnormal salts, okay, but it's just a joke, okay. Now first, normal salt, very simple. So this salt is formed by complete replacement of ionizable hydrogen atoms, okay, of an acid. Now we have seen how the replacement is been taking place, okay, of ionizable hydrogen atoms. Now by whom? By metallic ion or ammonium ion. Okay, very simple definition. We have gone through this already. Now, here examples we would see and then it would be clear to us. NaCl. So see, complete replacement of this hydrogen atom, okay, ionizable hydrogen atom of HCl. It is only having one ionizable hydrogen atom and it is getting replaced by Na plus, right, the metallic ion. Same way, Na2SO4, right, this is sodium chloride, we all know. This is Na2SO4, I have told you, this is sodium sulfate, okay, right, and this is formed by the complete replacement of the ionizable hydrogen atoms, two ionizable hydrogen atoms of H2SO4, okay, are being replaced by 2 Na plus, correct, and it is forming Na2SO4. We have already seen the formation of this salt, okay, in previous slide. Then Na2CO3, this is sodium carbonate, okay, sodium carbonate, okay, because this is carbonate ion, so sodium carbonate. It is formed by complete replacement of the ionizable hydrogen atoms of H2CO3. There are two ionizable hydrogen atoms, they are getting completely replaced by 2 Na plus ions, okay. Here Na3PO4, sodium phosphate, okay. Now how I am naming it? Very simple, na? Sodium, okay, and PO4 3 minus ion is phosphate, so sodium phosphate. Now it is formed by complete replacement of the ionizable hydrogen atoms of phosphoric acid. There are 3 ionizable hydrogen atoms of phosphoric acid, okay, H3PO4. These are being replaced by 3 Na plus ions, okay, completely they are getting replaced. Then CH3COONA. So this is sodium, again sodium, and I have already told you CH3COO minus, okay, in the starting of this video. Acetate, okay, sodium acetate, this is the name of this salt, sodium acetate. CH3COO minus is acetate ion, so sodium acetate. Now this is formed, try to guess from which acid it is formed, okay, you would be guessing right, CH3COOH, acetic acid, okay. This is the only ionizable hydrogen atom of acetic acid, right, and it is getting replaced by Na plus ion, okay. So it is having only one ionizable hydrogen atom and it is getting replaced, okay. So there is complete replacement of ionizable hydrogen atoms of this acid. And here one example I have taken for the complete replacement of the ionizable hydrogen atoms of an acid by ammonium ion, okay. So here it is formed from H2SO4, all the 2 ionizable hydrogen atoms are being replaced by NH4 plus ions, okay, ammonium ions. Now this is called, the name of this salt is ammonium, okay. Now you would guess sulfate, correct, SO4 is sulfate, so ammonium sulfate, right. Now let's see 2 reactions, okay, for the formation of normal salt. One we have already seen, H2SO4 and the NaOH reaction, which was giving us Na2SO4, right, we have already seen. Another reaction, let's see for NaCl, very simple salt, okay. So HCl, it is made from HCl, okay, I have told you. And what is happening, this ionizable hydrogen atom of HCl is being replaced by sodium ion, okay, metallic ion, Na plus ion. Now I have taken NaOH. So acid and base react, okay. So Na plus Cl minus, okay, forming NaCl, H plus OH minus, forming water, okay. So in this case, complete replacement of the ionizable hydrogen atom of an acid by the Na plus ion, giving rise to formation of NaCl, which is our salt, okay, and water. Very clear. One more interesting thing about these normal salts is they do not have any ionizable hydrogen atoms, okay. Now no more ionizable hydrogen atoms in these salts. Can you see here any hydrogen atom, means can you see here hydrogen atom itself? There is no hydrogen atom itself, but now in this case CH3CONA, there is hydrogen atom, but now this is not ionizable hydrogen atom, we know, right. In this case also NH4 twice SO4, these are the hydrogen atoms, but these are also not the ionizable hydrogen atoms. So in these salts there are no ionizable hydrogen atoms. Now let's see the next type of salt, acid salt, okay. So these are formed by, now normal salts were formed by complete replacement of ionizable hydrogen atoms of an acid. Acid salts are formed by partial replacement of ionizable hydrogen atoms, okay. of polybasic acid, okay, not just the acid. Here the acid should be dibasic, tribasic, okay. The acid should not be monobasic, okay, because in case of monobasic there is only one ionizable hydrogen atom, right? So the removal of that hydrogen atom would mean in the sense that there is complete replacement of ionizable hydrogen atom, but we want partial replacement of ionizable hydrogen atoms. So that's why we need to take polybasic acid for the formation of such salts, and these partial replacement of ionizable hydrogen atoms is taking place by metallic ion or same ammonium ion, okay. Examples, we would see the examples to understand the salts. NaHSO4, we have already seen this. I have told you the name. Okay, sodium, okay. If I haven't, it's the name here, okay, sodium. Then what is hydrogen, right? Sulfate. So sodium hydrogen sulfate, okay. Then NaHSO3, okay. So same sodium hydrogen, okay, sodium hydrogen sulfite, okay. SO3 is sulfite ion, okay. This was SO4 is sulfate ion, so sulfate. This is sulfite, okay. Now in this case NaH2PO4. So what it is this? What is this? Sodium. Now here there are two hydrogens, okay. So sodium dihydrogen phosphate, okay. And here in this case, now here see there are two sodium, so disodium, okay. Now don't apply this logic to Na2SO4, disodium sulfate, okay. Here in this case for phosphates only we are writing the sodium as sodium if it is 1 and if it is 2 disodium, okay, for phosphates, the salts of phosphates, not for other salts, okay. So see disodium hydrogen phosphate, okay. Now let's see how these are acid salts. See H2SO4, one ionizable hydrogen atom is replaced by Na plus, so partial replacement, okay. Another is still with that, another is still there, okay. Same NaHSO3, so H2SO3 sulfurous acid, out of in the sulfurous acid there are two ionizable hydrogen atoms, but only one is being replaced by one Na plus. Same from H3PO4, see two ionizable hydrogen atoms are still there, only one is being replaced, so partial replacement. Same here from H3PO4, two ionizable hydrogen atoms are replaced, okay, but one is still there, so it is also partial replacement, okay, and they are replaced by Na plus ions. Very clear. Now let's see the reaction, okay. So we have already seen the reaction, which is simply H2SO4 plus NaOH, right. Partial replacement means only one hydrogen atom would get replaced, so remaining part would be HSO4, right, minus Na plus HSO4 minus NaHSO4, right, and one H and one OH would form water. So we have already seen this reaction, okay, in detail. So see NaHSO4 sodium hydrogen sulfate, we can also call this as sodium bisulfate, okay. Since this also sodium hydrogen sulfide, so we can also call them as sodium bisulfite, okay. Very clear about the names of these two salts as well as the reaction. So now what we can see here, when we are taking the base in insufficient amount, okay, see here NaOH we are only taking one molecule and then we are treating it with H2SO4. What is happening? Bichara NaOH, it is only having one Na plus, so this one Na plus is able to only replace one H plus, right. So that's why partial replacement is taking place, and that's why acid salt is being formed. So why it is being formed? Because we are not taking sufficient amount of base, okay. So when the amount of base is insufficient for complete neutralization of acid, so acid salts are formed, okay. Now what does this mean? Complete neutralization means, complete neutralization simply means complete replacement of the H plus ions of the acid, okay. Very clear. And the term neutralization, okay, this entire reaction I have told you, this is neutralization reaction, okay. What is neutralization reaction? Reaction of acid and base to form salt and water. Okay, this is called neutralization acid. But in this case here, complete neutralization of acid simply means complete replacement of the ionizable hydrogen atoms of the acid. Okay, now moving ahead, these acid salts are having, yes, they are having ionizable hydrogen atoms, and because of these ionizable hydrogen atoms, they are releasing hydronium ion in water like acids. Okay, now let's see how they are taking, how they are managing this thing to do. So see this NaHSO4, okay, what is happening? This NaHSO4, this salt is getting dissociated. Okay, so aqueous, it is getting dissociated in Na plus and HSO4 minus. Okay, Na plus and HSO4 minus, we know these are the two ions, okay, from which it is formed, so it would get separated simply. Okay, this is dissociation, aqueous, aqueous. Now we know that this HSO4 minus won't remain chupchap, okay, won't remain quiet. This would again get ionized. Okay, so I am writing here, so this HSO4 minus ion will get ionized, okay, and it would form CH3O plus, right? This H plus would jump to water, it would say I am rid of this sulfate. Okay, so I am just coming to you, and this H plus and H2O forms H3O plus, okay, and the remaining part is SO4 2 minus, right? SO4 would remain and it would have charge SO4 2 minus. So what is getting formed? See, hydronium ion. Therefore we are saying that since they are having ionizable hydrogen atoms, they are releasing hydronium ion in water like that of acids. Okay, who? The acid salts. Now let's see the last type of the salt, which is basic salt. Okay, now this basic salt is formed by, again, partial replacement, like same like that of the acid salt, but here the partial replacement is of OH group, okay, of a polyacidic base by an acid radical. Okay, now this acid radical term is new to you, but you know what is polyacidic base. Okay, now let's understand this with the help of an example. So I am taking this first example, PbOHCl. Okay, so in this, the salt PbOHCl is formed, okay, because this is a basic salt, so this is formed by the partial replacement of the OH group of polyacidic base. So which polyacidic base? This polyacidic base, PbOH twice. Okay, now polyacidic means di-triacidic, right? So this is a diacidic base, diacidic base. Now why am I calling it diacidic base? This base is actually insoluble in water. So in case of insoluble bases, we know acidity is equal to number of replaceable OH minus, right, ions, okay, of the base molecule. So here the replaceable OH minus ions are 2. Okay, so therefore it is a diacidic base. Now what is happening? Partial replacement of the OH group of this diacidic base. So out of this 2 OH group, only one OH group would get replaced. So this is called as partial replacement of OH group of this diacidic base by an acid radical. Now what is an acid radical? Acid radical means, suppose I am having this acid HCl. So when I would remove this H plus, okay, of HCl, what would remain? Cl minus, and this Cl minus is acid radical. Okay, so I am taking this HCl, okay, now this is base, I am taking this acid, they would react with each other, okay, and what is going to happen? This acid radical is going to replace the OH group, okay, partial replacement of the OH group of the polyacidic base by an acid radical, by acid radical here in this case Cl minus. So it is going to replace one OH, so what would happen? PbOHCl would be formed, right? One OH is replaced, okay, by Cl. So what would happen? Pb, one OH is still there, and then Cl, PbOHCl, right? And one OH here which is being left, okay, and this H plus, this OH minus would form water, simply. Okay, so with this we have understood how the reaction, okay, is taking place for the formation of basic salts. Okay, now other examples are MgOHCl, just like Pb, you just replace it with Mg. Okay, so magnesium hydroxyl group and chlorine group. In place of magnesium you replace with copper, so copper CuOHCl. Okay, this is also an example. So these are formed by, see, partial replacement of the OH group of MgOH twice. Okay, this is the diacidic base. Okay, same way CuOH twice. Okay, it is formed by the partial replacement of the OH group of the diacidic base. Okay, CuOH twice by acid radicals. In both the cases, the acid radical is Cl minus. Okay, just like the PbOH type. Okay, so now it's time to see some questions. Okay, so first one is fill in the blanks from the choices given in the brackets. An alkali which completely dissociates into ions is dash. Okay, so in the sense they are asking us that which among these three is a strong alkali, because no, strong alkalis are the alkalis which completely dissociates into ions, right? Weak alkalis do not completely dissociate into ions. Okay, so they are asking us which among these three is a strong alkali. Simply, so we know ammonium hydroxide, which means NH4OH, calcium hydroxide, which means CaOH twice, okay, and lithium hydroxide, LiOH. Okay, now you can pause the video here and you can think by your own which among them is a strong alkali. Okay, okay, fine. So I hope you would have the answer, and yes, we have already studied this. LiOH, it completely dissociates into its ions, so this is strong alkali. Okay, LiOH. Next, differentiate between the following pair based on the information given in the bracket. Okay, first means which pair is given? Acid and alkali. Okay, now the previous question was asked in your exam in 2020. Okay, now this question is also asked in your exam in 2020. So what we have to do, we have to differentiate between the acid and alkali pair based on the information given in the bracket. Information is formation of type of ions. So acid and alkali, which type of ions they form? So we have just studied in the definition itself. Acids form H3O plus ions, right? Hydronium ions as the only positive ions when they are dissolved in water, right? Or we can also say acids form H plus ion as well. Okay, because these H plus ions in turn they form a bond with water molecule and form H3O plus. Okay, so you can either write H plus or H3O plus. In case of alkali, we have also seen in the definition itself, these are the bases which dissolve in water and form OH minus ions as the only negative ions, right? So based on the formation type of ions, acids are forming H3O plus and H plus ions, while alkalis are forming OH minus ions. So we have differentiated it. Okay. Next, give the appropriate term defined by the statements given below. So a statement is given, we have to give an appropriate term. Substance that releases hydronium ion as the only positive ion when dissolved in water. Okay, now just now we have seen acid, right? And we have also studied the entire Ramayana of acid, right? So now we know that this is the substance which releases only the hydronium ion as the only positive ion when dissolved in water. Okay, if you feel, you can go back to the acid section which we have learned, and then you can just see, okay, in detail. So the answer is this substance is a acid. Okay, and this was asked in your exam in 2019. Now let's see some more questions. Next is monobasic acid forms dash. Okay, now the options are normal salts, acid salts, both normal and acid salts. Okay, so we have to now apply the concept, right, which we have studied, monobasic acid. So the easy way to apply the concept is just take an example, very simple, right? So monobasic acid, this is an acid. Okay, monobasic means basicity is 1, right? Basicity is 1, which means that it is forming 1 H3O plus, okay, when it is dissolved in the water. Okay, so which means it is ionizing to form 1 H3O plus ion. Its one molecule is ionizing to form 1 H3O plus ion in aqueous solution. So 1 H3O plus ion, which means it is having 1 ionizable hydrogen atom. So I just took an acid which is having 1 ionizable hydrogen atom, HCl, simple. Now this monobasic acid, okay, it has only 1 ionizable hydrogen atom. Now we know normal salts are formed by the complete replacement of ionizable hydrogen atoms. So here, yes, we can completely replace this H plus ion, okay, and normal salt can be formed. Acid salts, okay, so normal salt can be formed. Okay, first acid salts are formed by the partial replacement of the ionizable hydrogen atoms, right? But for partial replacement, there is only 1 hydrogen atom which is ionizable. So when we would replace it, it would be complete. So no chance of partial replacement. So acid salts are not formed by monobasic acids. And the third option, both normal and acid salts, it won't be applicable because acid salts are not formed. So our right answer is normal salts. Okay, very simple. So this is the way you have to apply the concept, okay, in exams or whenever someone asks you such questions. Now dibasic acid forms dash, okay, normal salts, acid salts, both normal and acid salts. Now same logic, dibasic acids, acids having basicity 2. Now I won't repeat the entire process, okay, I'm just directly going to take the example H2SO4. Okay, now you know how to reach the example, okay, like the first case we did. In the same case, in the same way you have to in the same way you have to reach the example for the dibasic acid as well, okay, by applying the concept. Now H2SO4, this acid, now normal salts we know by the complete replacement of ionizable hydrogen atoms. Yes, both of them can be replaced and can be replaced to form a salt, right? So normal salts can be formed by dibasic acids. Now acid salts require partial replacement. So we have already studied. See, one H plus ion is being replaced by Na and resulting is NaHSO4, right? This salt we have studied in acid salts. So what is happening? Out of these two, one is only getting replaced. So partial replacement is also possible for H2SO4 for dibasic acid. So this means that it is also forming acid salt, right? Partial replacement it's possible, therefore it is forming, so therefore it can form acid salt, right? And third option is both normal and acid salt. So yes, third one is our right option, okay. Since it can form normal and acid salts, our third option is correct, absolutely correct. Both normal and acid salts can be formed by dibasic acid, okay. Now next, give the basicity of nitric acid, sulfuric acid, phosphoric acid. So first we would write the formulas, it would become easy for us. Phosphoric acid H3PO4, sulfuric acid H2SO4 and nitric acid HNO3. Now what is basicity? We all know the number of H3O plus ions, okay, hydronium ions formed by the ionization of one molecule of the acid in aqueous solution, right? So HNO3, okay, it would give only one H3O plus ion since it is having only one ionizable hydrogen atom, okay. So its basicity would be 1, right? H2SO4, it can give up 2 hydrogen atoms to form hydronium ions, okay. So 2 hydronium ions can be formed because it is having 2 ionizable hydrogen atoms. So since 2 hydronium ions are formed, therefore basicity would be 2. And same phosphoric acid we have already learned, it gives all the 3 hydrogen atoms to form hydronium ions, right? Because it is having 3 ionizable hydrogen atoms, right? So 3 ionizable hydrogen atoms react with or form bond with 3 water molecules, form 3 hydronium ions. 3 hydronium ions are formed, which means that basicity is 3. Okay, very simple. Now the last question, give the acidity of LiOH, calcium hydroxide and ferric hydroxide. Okay, so we are going to just apply the concept. Now what is acidity? We all know it's just the number of OH minus ions which are produced by the dissociation of a molecule, of one molecule of base, right, in aqueous solution. Very simple, we have learned its definition. So this means here LiOH would dissociate, okay, its one molecule would dissociate and it would form one OH minus ions, okay. So one OH minus ions is formed, which means acidity is 1. Similarly, in case of calcium hydroxide, it would dissociate and it would form 2 OH minus ions, so acidity would be 2. And in this case, FeOH thrice, it won't dissociate at all, right? But it is since it is a water insoluble base, okay, water insoluble alkali, not alkali, sorry, water insoluble base, okay. Now, since it is a water insoluble base, so acidity in such bases is simply equal to the number of replaceable OH minus ions, okay. Now we have already studied, okay, that FeOH thrice, AlOH thrice, they are having 3 replaceable OH minus ions, because since in this case you can see FeOH thrice, it reacts with 3 HCl, okay, just like the AlOH thrice, and it forms FeCl3 and 3 water molecules, okay. So I have explained this type of equation which is of AlOH thrice in very much detail. If you feel you want to know this equation, if you feel you want to understand this equation again in very much detail, you can go back to that section where we have studied about the triacidic bases, so that you would be able to understand how this reaction took place, okay, how this reaction has taken. And with this we have reached the end of this video, and I hope you would have enjoyed learning with me, you would have understood all the concepts. But please do let me know in the comment section whether you have enjoyed, whether you have understood the concepts or not. and we will meet in the next video with the remaining concepts of this chapter. So as you all know, LearnoHub matlab free hai par best hai. So till then, bye bye, take care and have a great day.